Hello, everyone. Today we are going to talk about transformations on quadratic functions. So a translation is a change in the position of the figure, either up, down, left, right, or diagonal. Adding or subtracting constants in the equation of a function translates the graphs. So the graph g of x equals x squared plus k is the translation of x squared vertically. So when we add a constant, if that constant is greater than 0 or positive, that translates the entire graph up. If k is less than 0 or negative, it translates it down. Now, when we want to translate horizontally, we have to put it inside the parentheses of what's being squared. So that's when it's translated horizontally. This is when h is greater than 0, it goes right. So that's when it's minus inside our parentheses. And when h is less than 0, it goes left. So let's take a look at a couple of examples. So here we have g of x equals x squared plus 4. Since we're adding 4, what that did is it moved it up 4 units. So it went up 4. Here, it's x plus 3 squared. So that is actually x minus negative 3 squared, because when we're talking about horizontally, it's always x minus h squared. So it's minus a negative 3. So that actually went left 3. So if we look at our vertex, we went left 3. So now let's try some. So when we look at number 1, it's plus 1, a constant outside. So that went up 1. Here, it's x minus 6 inside our parentheses. So that is right 6. Here it's x plus 1 in parentheses. So that is left 1. Because again, our rule is x minus h squared. So if it's plus inside, that means it actually went left. So I want you to pause. And I want you to do 4 through 9 and come back and check. So number 4, it's x squared plus 20. So that's up 20. Number 5, it's x minus 2 in parentheses. So that's right 2. Number 6, it's minus 1/2. So that's down 1/2. 7, it's x squared plus 8/9. So that's up 8/9. 8, it's x squared minus 0.3. So that's down 0.3. And 9, it's x plus 4 in parentheses. So that's left 4. Now, the other transformation we can do is a dilation and a reflection. So a dilation is a transformation that makes the graph either narrower or wider than the parent graph. A reflection flips a figure over the x or y axis. So the graph f of x equals ax squared is a stretch or a compression. Stretch, it's narrower. Compression is wider. So if the absolute value of a is more than 1, so that means we're ignoring if it's positive or negative. If it's more than 1, it's stretched. It got thinner. If the absolute value of a is between 0 and 1, so in other words, a fraction, it got compressed, so it got squished. Now the graph of negative f of x flips the graph across the x-axis. And the graph of f negative x flips across the y-axis. So describe the graph of each function. So here it's g of x equals 2x squared. So 2 is greater than 1, so this became stretched vertically. Letter B, the negative sign caused a reflection across the x-axis. That's what makes our parabola sad. Dilation of 1/2 is a compression, and it's also translated down 3. So it's reflected across the x-axis, dilated wider than the normal, and translated down, so it's compressed. So let's do a couple more examples here. So number 10, the negative is it's reflected over x-axis. And the 5 is greater than 1, so it's vertically stretched. Here, this minus sign is a reflection over the x-axis. Then in parentheses, we're adding 1, so that's left 1. 12, here we have a minus sign, so that's reflected over the x-axis. We go in order of operations. The 1/4 is a vertical compression. And then the minus 1 is translated down 1. So I want you to pause, and I want you to try 13, 16, and 19, and come back and check. So number 13, that was a translation up to. 16 is a vertical stretch. 19 is a reflection over the x-axis and a translation up 3. So that's the end of our video. If you have any questions, please ask tomorrow in class.